Hello, friends. Part 3 of your podcast on Chapter 6 in the regular stats book. On page 105, you have this example, and this is pretty straightforward, but I'll just point it out that this can happen. They're doing a medical study, and they start out with 1,187 obese subjects. There were 892 subjects left here. The subjects were assigned, blah, blah, blah. And after a year devoted, only 576 subjects were still participating. After the second year, there were only 403 subjects left. So then, of course, it arrives, can we trust results where so many subjects drop out? So you should read this, but the answer is pretty obvious. There's probably differences between the people that would stick out this study for a long period of time and those that would drop out as it progressed. Another important idea is this idea of generalizing. So if I do a study, we had an example in the last chapter where it was a bunch of doctors that took pain medicine and they got a certain result about how the medicine affect heart attacks, I think it was. But those results don't generalize to other groups. So it doesn't mean that they'll work with women. It doesn't mean that they'll work with young people. They might be the same, but very often they're not. So when we generalize, that means we apply any statistical significance, but we can only apply what we learned to a population that's similar to the sample we used in our study. So if we want to generalize results to people that are senior citizens as well as people in their 20s or middle-aged or whatever it is, we have to include all of those people in our experiment if it's a completely randomized design. But we could also block our experiment, which is the next. And you should remember from our discussions already that blocking or breaking a population into different strata means just comparing different groups. All right. So let's make sure we understand all of the designs. First, completely randomized design is like most of the experiments we've talked about. Completely randomized design here on page 86. No distinction between the patients. We've got completely randomized design with fish. Okay, we've got these treatments here. So we're not making any distinction between the subjects. But our results will only apply to the population that is similar to the people that we ran our experiment on. On page 109, you've got a good example here of completely randomized design. You've got two different length commercials that are shown three different numbers of times throughout a TV show, and they compare the results. So this is a good example to read about completely randomized design. In a block design, we compare groups within, typically men or women, but it could be by age, it could be by health issue, it could be by anything at all. In this example, they take the same design, the same experiment that was completely randomized that I just showed you, and they do a block design. They just break up the sample that they have into women and men so they can see, is there a difference between the effect of the ads on women and men. So that's the difference between a block design and a completely randomized design. Finally, a matched pairs design is most often when I do two different treatments or more to the same person, because then I can compare, instead of having two different groups, there's still going to be differences between them. But if I have the same person do both treatments, whether it's an ointment for dry skin or a pain reliever or anything, that's a good way. So I have the exact same experiment performed on the same person. Another way of doing it is to choose pairs of partners, pairs of subjects that are closely matched as possible. So same sort of age, size, health level, education level, whatever it is, blood type, could be anything. So either do the same treatment on the different treatments on the same person, or pick pairs of people that are very similar to do the experiment on. And example 9 is probably the most common type of match pairs, where you do a Coke versus Pepsi or a taste test. And we randomize, in this case, we're still randomizing, but we randomize which treatment goes first and try to balance that out. So that's it. Those are the big ideas. We'll see you in class.